Alright, so exercise 16A1, 5x and 3y equals to 2. And also we have 5x plus 3y equals to minus 7. Alright, now if you compare these two here, let's try the substitution method. We can definitely rearrange the equation, but it's going to be too tedious because you're given this in the general form. The next one is to try to eliminate. Problem with the elimination is that you have two terms having the same term as well. 5x and 5x, which are both positives. 3y and 3y, which are both positive as well. Now, having said that, looking at this, alright, looking at this one here, if we try the substitution method and we try to rearrange, let's just say, you have equation 1 rearranging into 3y equals to minus 5x plus 2. And if we try to rearrange 2 as well into 3y equals to minus 5x minus 7. And of course from here y is equivalent to minus 5 out of 3x plus 2 over 3. And over here y equals to minus 5 out of 3x minus 7 out of 3. Okay, we might think, okay, we'll try to, have the same substitution by having y and y being equal. But having said that, let us look back into your coordinate geometry factors. Alright, the chapter is actually very important because if we compare these two here, side by side, alright, if we compare these two side by side, do you notice your two gradients? Are they equal or are they unequal? They're both equal. What does that suggest to you? Good. Both of them are parallel lines. So if we know both of them are parallel lines, will they ever meet? Never. That's the very sad thing about parallel lines. No matter how far they stretch, you will never meet. Very sad world if you're in a parallel world. You can never meet. You can only contact. They can only say hi and bye. They can never meet at any point. Alright? So again, this is a very good trick question. Alright? And if some of you have picked it up, good job. Alright? But in the meantime, let me just do a little bit more of the substitution and also elimination method. Alright? So if you turn to page 348, alright, 348. Let's try question 5. Try to solve by substitution y equals to 3x plus 1 and also 6x minus 2y equals to negative 2. Could I ask you guys, what is the condition for a substitution? Anyone? Yep, that's correct. So in this case here, equation 1, which you will label it, and also equation 2 given here, you know that equation 1 has a stand-alone variable, which is just y alone. So therefore we can say substitute 1 into 2. Alright, substitute 1 into 2, which means we will take equation 2 here, 6x minus 2y. And we know that y given here is 3x plus 1. So we substitute 3x plus 1 into y. And that will be equivalent to negative 2. Looking at this here, we will definitely expand it. Alright, so 6x minus 2 times 3x will give you minus 6x. Minus 2 times plus 1 will give you, what would the answer be? Anyone? Yep. Alright. So you have 6x and also minus 6x here. So therefore these two will cancel out and you're left with negative. Now something is wrong in this case here. Something is wrong in this case. So 6x minus 6x will give you 0. So negative 2 is to negative 2. So ultimately, what we can see here is, do you reckon that this is a parallel line as well? Should be a parallel line, because this is a very tricky part, but usually in the exam situation or even in a test, we won't give you such a thing. But if you can say that 6x and 6x has been deleted, what we can conclude from here is that, alright, you can just write here unresolved. Alright, what we can say here is equations 1 and equations 2 are parallel to each other. Okay? Right, all good with this one here? So 1 and 2 are parallel to each other. Okay. Have you guys gotten this so far? All good? Okay. Anyone still copying? Yes. Right, so most important thing here in substitution, make sure one of the variables is a standalone variable that is the subject. So in this case here, y is the subject. Alright, now having said that, this has been recorded, so if you can't catch up, that's alright. We'll move on with question 6 in the same exercise. Let's just say you're given these two equations again, but the question this time asks you to rearrange equation 1 so that y is the subject. So you can say from equation 1, you will have 4x plus 5y equals to negative 4. And if we want to rearrange y to be the subject, we have to make sure that y is on the left hand side. So 5y will be on the left hand side, and you bring over negative 4x to the, you bring over 4x to the right hand side, so it becomes negative 4x minus 4. And in this case, because we want only y, so y is equivalent to minus 4 over 5x minus 4 over 5. Okay, so we have really rearranged this so that y is the subject. The second part is asking you to solve it by a substitution method. And we did mention what is the condition for a substitution method. Anyone? Come on, just answer. Not going to eat you. You must have a standalone subject. You must have one of the variables to be a standalone subject. In this case, y is your subject. So therefore, that is the condition if you want to solve it by this method. But anyhow, this here has sort of like become a new equation. So we put it as 3. Okay? So now we're going to say, we're going to substitute equation 3 into equation 2. Alright, so 3x plus 2y equals to negative 5. And that will give you, of course, 3x plus 2 multiplied by minus 4 over 5x minus 4 over 5 equals to negative 5. Okay, and in this case, we just have to expand. 3x is minus 8 over 5x minus 8 over 5 equals to negative 5. And in this case here, we can bring the minus 8 over 5 to the next door, to the right hand side, and that will become minus 5 plus 8 out of 5. Okay, now having said that, we're going to bring this over to the next bit. I'm going to rewrite this equation. Can someone use your calculator to calculate 3 take away 8 over 5? Having said that, because these two terms are actually equal, they have to... Sorry? 1.4. So could I just have it in fraction form, please? 1 and 2 over 5. Having improper fraction should be 1 and 2 out of 5. So that would be, sorry? 7 over 5. 7 over 5x. And minus 5 plus 8 out of 5. Anything in fraction? Okay, so again, x is minus 17 out of 5. You have to inverse this because if we are dividing it by 7 out of 5, if you inverse that multiplication, it will be multiplied by 5 out of 7. So the 5 and 5 will cancel and you have negative 17 out of 7, and that is for your x value. And now we want to solve it for y. So having said that, because we have known that x is minus 17 out of 7, is a negative number, all we need to do is to substitute that x into which equation. So let me bring over this here for a while. You have equations 1, 2 and also 3. Which is the best to get the y value straight out? Equation 3. So therefore, we substitute x equals to minus 17 out of 7 into into 3. So y is to minus 4 out of 5 times negative 17 out of 7 minus 4 out of 5. Alright? And so, what would the answer be? Answers. I need answers. Answers, anyone? This is being recorded. Yep. Thank you. At least someone's willing to do it. Hmm? Mm-hmm. Negative 96 out of 85. Okay. Just double check. Is it negative 96 out of 85? Double check with your calculators, guys. Sorry? 8 over 7? Okay. So it's not this number, but is it negative or is it a positive number? Positive. So it's 8 over 7. Okay. So therefore, thank you. Thank you for all the confirmations. So therefore, we have solved x, we have solved y. Question, have we really solved this here? What do we need? What do we need? No, no, no. Because we have already done x, and now we have already done y. Final sentence. Good. I need a final sentence. Therefore, x is minus 17 out of 7, and also y is 8 out of 7. Okay, so I'll just leave this here first. Alright. All good so far? Alright. right, see you. Okay, I'm going to continue. So that was the substitution method. Now let us move on to the elimination method. Okay. It's not very nice. Anyway. So exercise 16C, page 350. Let's try question 6. Part A. You have 2x minus y is to 3 and also 4x minus 2y is to 6. Okay, so now again the first thing you have to do, just make sure that you label 1 and label 2, indicating is equation 1 and also equation 2. Alright, whatever that you do, make sure you highlight each of them with what sort of equation. Is it equation 1? Is it equation 2? Make sure of that. Now having said that, for elimination to occur, what is the condition? What do we do with one of the terms here? Yep, you need one of the variables to have the same term. So in this case, what we can do is we have 2x minus y is to 3, 4x minus 2y equals to 6. So what we can do is we try to make one of the terms to be similar to the next one. So if we take equation 1 here, for example, alright, 2x minus y equals to 3, and let's just say, right, we want to try to solve for x first. So what we're going to do, or rather y, sorry. So what we can do in this case, we can have equation 1 and we can multiply it by 2. And the reason is because when we multiply by 2, we get 4x minus 2y equals to 6, and that will be a new equation, and we'll write equation number 3 here. Alright. Compare this with equation 2. Do we have two terms of the same term? Yeah, two variables of the same term, 4x and 4x. Yes, we do. So what we can do is we'll check the next variable. We have minus 2y and minus 2y at the same time. So in this case, we want to get rid of the 4x. So what we can do, we have equation 2 and we take away equation 3. Alright, so we are left with 4x minus 2y equals to 6, and also 4x minus 2y equals to 6 as well. Okay, now having said that, this is actually quite interesting. If we are going to take this away, like we have said, so 4x minus 4x is to 0, minus 2y, take away minus 2y will be 0, 6 minus 6 would be 0. This is another ambiguous case whereby you can say that both x and also y are literally 0. So if you cannot find anything based on this, what does it mean in this particular equation? What can you conclude about those two equations? Sorry? Both of them are parallel. Alright, so this is a very interesting exercise to actually test you whether you know how to solve it, and then from there you just say, because x and y are both 0, we can say that both equations are parallel. Okay, now there is one section that I want to go to, which is the problem solving question. Okay, the problem solving question, like any other questions you have solved in trigonometry, in quadratics, will require you to read the question properly, highlight the important variables, and then finally write down your conclusion. So if we move on to exercise 16D, page 351, we'll try question 1 first. Okay, the question is, the sum of two numbers is 72. The difference is 40. Find the numbers. Whenever they give you simple problems like this, read the question properly. You talk about the two numbers. So what are those two numbers? Alright, the two numbers are both x and y. This is part of your working. You have to write things down. You have to collect the information from the problem and you have to write it down in words. So this is part of your working. Do not skip just because you only need to solve the equation. Make sure you have the information written on as well. Alright, and your difference, the sum of two numbers is 72. So having said that, the sum of the two numbers, x plus y, equals to 72. And the differences would be 40. So x minus y equals to 40. Okay, now in this case, some of you might ask me and say, oh, can I do the elimination method? You can use the elimination method because one of your variables, in fact two of your variables here, alright, are of the same term. But the thing here is, one is positive and positive, the other is positive and negative. So the best way to get rid of that y is to add it together. So we have labeled this as equation 1 and equation 2. So therefore we will say, right, equation 1 to equation 2. You will have x plus y again equals to 72, x minus y equals to 40. So take away, we'll do step by step. X minus x will give you 0. Y take away minus y will give you 2y. Is that correct? 72 minus 40 will give you 32. So therefore y is to 32 divided by 2, that will give you 16. Alright, now we have gotten y. We just need to find out for x. Now in this case here, it's best if you rearrange one equation and then to substitute. That is what we have done in the formula chapter. Okay, so again, you can substitute into any of those equations, equations 1 or 2, provided you can get the answer. So if we substitute y into 1, for example, okay, we have x plus y equals to 72. We want to find out the value for x, so x here is 72 take away y, and therefore we say 72 take away 16 as we have substituted, and that will give you 56. Okay, now that is only just the working. Are we actually done with the whole thing? What do I need in this case? Sorry? The ending sentence. Good job there. So you have x equals to 56 and also y equals to 16. Alright, this is the final sentence that I mean. Or you can say the two numbers are x equals to 56 and y is to 16. Okay, so that is how you do a proper working. Okay, let us now try question 4. Okay, question 4. The question states, question 4. 3 pieces of fish and 2 serves of chips cost a total of $8.10. 5 pieces of fish and 3 serves of chips cost a total of $13.25. Find the cost of each piece of fish and each serve of chips. Alright, this is a complicated problem, but you have to sort of like narrow it down bit by bit. So in this case, we have 2 unknowns. We have the fish and we also have the chips. Alright, let us say that fish here is your x variable and the chips here will be y at the same time. Okay, so what we can do in this case is this. You have 3 pieces of the fish, so 3x, and also 2 serves of the chips, 2y. That will cost you $8.10. But of course, in this case, we will try to avoid decimals. So if we can convert the dollar sign of $8.10 into 810 cents, we'll just leave it as 810 because what you want to do is to make sure you have whole numbers. Okay. The next one, we have 5 pieces of fish, 5x, and also 3 serves of chips, that would be 3y, and that will give you $13.25. So if you convert it into cents, it would be 1,325 cents. Okay, and we have this as equation 1 and also equation 2. Now, having said that, you will come to a point where you have to think, do I eliminate or do I substitute? Because having a look at this, you can do both, but then you have 3x and 5x, which is the same term, but you have different coefficients. You have 2y and also 3y. So it is impossible for you to eliminate on the basis that you can just solve the equation. Here, you have to turn one of the equations to be equal to one another. But looking at it, 3, 2 and 5, 3, there is no chance. So what you have to do is you have to make one of the variables as a standard variable. So in this case, what I can do, I can multiply this by 3. Why do I multiply it by 3? Because I want to have the 6y and the 6y to be of the same value. So we multiply this by 3, you will get 3x, no sorry, 3 times 3 is 9, apologies, and also plus 6y equals to 2,430. Okay, 5x plus 3y, I multiply this by 2 so that I can have 10x plus 6y equals to 2,650. Okay, then only at this point we can say, oh, alright, so we have 6y and 6y, not a problem. So what we're going to do here is, having said that you have done equations 3 and 4, we will say, take equation 3, take equations 3 from equation 4. Alright, rewrite this. And what you'll be getting is 9x minus 10x. What would it give you? Excuse me? Negative x. Plus 6y minus 6y will definitely give you 0. And in this case, 2,430 take 2,650. What would it give you? Negative 220. Alright. So in this case here, what is happening? Negative x equals to minus 220, so therefore x is to 220 because you literally divide this by negative 1. Alright? To get x equals to 220. Okay? So, we are done with x. Now we need to substitute x into one of the equations to find out y, isn't it? So we can use any other because all you need to do here is rearrange one of the equations. So let's just say we say rearrange equation 1. Alright, you want to have your 2y here as the subject, or rather the y as the subject. So 2y is to minus 3x plus 810. So y is to minus 3 out of 2x plus, this is 4, 0 and also 5. Okay, so in this case here, now we substitute x into y. Sorry, we substitute not x into y. Again, because we are sort of like rearranged and we have done a new equation, we put here as equation 5. So x into 5. Right? And that will give you y is to minus 3 out of 2. What is x? 220 plus 405. Negative 330 plus 405 will give you 75. Thank you. Okay. So therefore x here is 220 and y is to 75. But what is the question? Find the cost of each piece of fish. Okay. So in this case here, we are not done because we have calculated x equals to 220 and this would be in cents. Good. 220 cents. y is 75 cents. So in order to do so, we have to say, right, therefore, the cost of x is 220 and the cost of y, oops, is 75 cents. Okay, that's your final statement. Alright, you guys alright with this? All good? Right, this is how you work it out. Sometimes it's not as an easy elimination or substitution that you can take. You have to consider eliminate it first, rearrange and substitute. So that is how you work it out. You can't necessarily get a straightforward elimination. You can't necessarily get a straightforward substitution. You have to rearrange it to tailor the particular problem. Okay? Alright, so this is all for simultaneous equation. The one that I'm going to do next is basically to solve it using graphical solutions. Alright, so that will be in a different recording. Alright, thank you guys.